Hello everyone and welcome to the channel once again. Today we are going to dive into the world of Groff, which is a powerful text formatting system for Unix-like environments. We'll specifically focus on the EQ and preprocessor with the MS macros, which can be used to create beautiful and complex mathematical equations in your Groff documents. If you guys are new here and have not seen my previous Groff video, Groff stands for the Groff macro processor and is a classical document formatting tool for plain text. It offers a high degree of control over formatting, which makes it ideal for technical documents and research papers, though it is not as widely used as the traditional Word or LaTeX. Groff can be used as a robust and lightweight option for its alternatives. The MS macros is a set of extensions for Groff, which is designed for documents like reports, letters, and books. Groff has similar such set of extensions for writing man pages and other stuff like that. Uh, Specifically for the MS macro package, it simplifies tasks like creating cover pages, table of contents, and various text styles. Importantly, the MS macro package also integrates with preprocessors like EQN, which is the focus of today's video. Now, the EQN preprocessor is a powerful tool for creating equations in Groff. We can't directly write complex math symbols within Groff, so instead, we use a special syntax within the EQN block, which I'll tell you what it is, to define the equation structure. So to get started, I have just created a basic Groff document which can be seen pretty familiar to those who have seen my previous video. Uh, so the .tl here stands for the title of the document. The .au stands for the author of the document. .nh, which can be remembered as new heading or numbered heading, is used to define the heading of the file of the file, yeah. And the .pp is used to define a new paragraph. So this is a pretty straightforward and basic graph document which is pretty self-explanatory. So to start using EQN in this document, we first need to define the EQN block. So the EQN block or the equation block is something like this. All the special syntax will be inside the .eq or the .en here. This whole thing is known as the equation block. So to get started, let's write a very simple equation. Uh, I'll keep my cursor between the EQ and EN, and let's write, for example, 3x plus 10 equal to 20. To compile this graph document, uh, we have to use, this may be pretty familiar for you guys, graph then dash ms to tell the compiler that we are using the ms macros, then dash e to include the EQ and preprocessor, and then the name of the file, which can be seen here as main.ms. So this will be main.ms. If we hit enter, this will uh, output the formatted file in something called PostScript. To convert this into, let's say, PDF, we have to type dash t and then PDF. Now, if we hit enter, this is in the form of a PDF. To see what is in this PDF, we have to redirect the output into a PDF file. So in this case, my PDF file is called as main.pdf. You can change this to any name you want. Now if we hit enter, the PDF file should be ready and we can view it. So yeah, after compiling the file, you will be able to see that graph here has successfully, well, there is nothing special in this, but you can see that it is centered. And if you write something else, which I'll show in a bit, it will be correctly formatted and special symbols will be used. Okay, so now let's give another example. So again in this, or else I'll create another EQ block. I'll add some text here as well. So now let's do something different, which uses special symbols. So EQ1 here can work with Greek letters as well. So for example, let's write pi. So EQ1 should substitute the word pi with the actual symbol of pi and then equal to, and let's do 22 over 7. So now over is a keyword used to describe what is the numerator and what is the denominator. So basically this is a fraction and this is a special symbol. So now let's say if this works. So now if I save the file and then again run the compilation command, you will be able to see that EQN has successfully formatted our syntax into what we wanted. So here is pi and then 22 by 7 correctly formatted as a fraction. All of these examples are rendering the equation on its own line. You can also render equations directly in sentences without placing them on their own line. These are known as inline equations. To use inline equations, you must first define a pair of delimiters. This can which basically defines what should be included in the EQN block, but which is inline. So this can be done using the delim keyword in an EQN block. So at the start of the file, I'll create another EQN block. In this, I'll write delim and then two dollar symbols. This syntax is mostly used in LaTeX and other uh, formatting systems. So I'll continue this in Groff as well. So now to create an inline, for example, an inline equation, what you can do is create a new paragraph, and then let's say this is the equation I was talking about, and then write two dollar symbols, and between these dollar symbols write the special syntax of EQN just like the way you will write in between the equation block. So again, let's do 3x plus 10 is equal to 20. And I can continue after this. For example, let's do this is so cool. Now if I save the file and recompile it, you will see that Groff and EQN together have created an inline equation. So to do something else, let's do pi plus 10. Oh, as you can see, pi has successfully been substituted and we can see the actual symbol of pi. Now one thing to note with EQN is that space, actual white space, does not matter in the equation. So for example, this equation here, and if I copy this one more time, and let's say something like this, will render the same output. So to check that, I'll save my file and recompile it once again, and you will see that both of them are outputting the same formatting and is ignoring the white space between the syntax. Now most of the time EQN's automatic handling of white spacing will be appropriate, but sometimes it can be pretty irritating. So to get so EQN has given us an option where you can write something in double quotes, and whatever is inside double quotes, EQN will preserve the space in it. So for example, let's write hello world. Now if I save this and run this once again, you will see that it has formatted the whole thing but it has also preserved the space in it. There is also another way to add spaces between different parts of the equation. So for example, uh, let's say this is our equation. So what we can do is we can add a caret symbol between these. Caret. Now if I save the file and rerun it, there'll be a slight difference between the white spacing here and there, and you can add uh, like various types of spacing in the equation blocks. There is another symbol which is the tilde symbol. This can also be used for spacing. Now we save the file and rerun it. There is a little more space between the different parts of the equation. Now let's do some more examples. So I'll clear this out. Yeah, and let's use some more special symbols. Let's do delta um, x is equal to uh, y delta, uh, let's do x plus 1, just some random equation. And then now if I save this and run this again, we got the output we are expecting. Now some of the keywords in Groff uh, are pretty not Groff, sorry, my bad, but in EQN are pretty easy to understand or read. So for example, the symbol for, let's say, the cross or the multiplication symbol is times. So for example, we can write 3 times 2 is equal to 6. Now if we run this, my bad, see, but you can see that this is converting the times keyword into a cross symbol. Another example might be, let's say, uh, the different comparative operators like greater than or less than or greater than or equal to, less than or equal to, much greater, much lesser, plus or minus, equivalent, something like this. All of these are keywords in EQN which will be substituted by the respective symbols, special symbols in the formatted document. There are also various set operations like inter stands for the keyword of set intersection and union is for the set union. So for example, let's do uh, A union B is equal to C. Now if I compile this, oh, I didn't save my file here. If I save this and then compile it once more, you can see that this has been substituted by the union symbol here. Similarly, if I change this to inter, this will be substituted by the intersection symbol. So now you may be wondering, or you may get into a situation where you want to format a line of an equation with an operator, for example, the square root operator. But if we write something like this, well, square root is the sqrt is the keyword for the square root operator in EQN. So now if I write something like this, you will see that it is not the square root line at the top is not going throughout the entire equation. So to do that, what we can do is wrap this in curly braces and save the file and now recompile it. And now you'll see that it has the square root is covering the entirety of the equation. So now let's do a more complicated example. Uh, let's say I want to write the quadratic formula in EQN. So to do that, I'll do x is equal to negative b plus minus square root of b square minus 4ac by 2a, not by over. So now there will be some differences in this. This you can is this is the basic thing, but if we run this, we'll not get a specific output. First of all, for defining superscript, you should not use a caret symbol, but you should use sup, as sup stands for super and sub stands for sub. After this, I have to minus b plus or minus square root of b square minus 4ac is in the numerator, while 2a is in the denominator. So if I wrap this whole thing, and if I save this and run it once more, well, these we are still not getting our output, and square root is not covering the entirety of the equation. So to do it, we again need to cover the whole thing in curly braces. Now if I run this, as you can see, that is our quadratic formula. Oh, my bad. Oh, sorry. This should be here. Oh, if I save the file again and run it once more, we can see that a quadratic formula has been successfully formatted using Groff and EQN. So, yeah, that is a pretty good intro for Groff to get you started. And by mastering EQN and other preprocessors in Groff, you can do a variety of things with it. It is a really powerful software which is used to write man pages. Uh, you can create professional looking documents with complex equations in Graph. It may have a slight learning curve, but the power and control it offers are worth the effort, especially for you guys who may do technical writing in the near future. So yeah, thanks for watching, guys. If you found this helpful, leave a like and subscribe for more graph tutorials. Uh, Please let me know in the comment section what other graph features you'd like to see. Uh, Peace, guys.